All right, guys, we are going to be opening up our books to page 47, which is graphing ratio tables. So we have spent time working and filling out ratio tables. Now we are going to be using those ratio tables that we either need to create or that are given to us and graph them onto a coordinate plane here. So I do want to review just a few things about the coordinate plane. So we're going to fill out this little section of the vocab startup here. So it says the coordinate plane is formed when two perpendicular, which means going in opposite directions of each other, just like our double number lines are, like that, intersect at their 0 points. So right here and right here, they're perpendicular with each other. 0 is where they intersect. This point is called the origin. So we're going to fill this in here. Okay, 0, 0 is what this is at, what point that is. Okay. The number horizontal, or the horizontal number line, right here, is called the x-axis, and the vertical number line is called the y-axis. Okay, so numbers that are given to you in a ordered pair, so like 5, 4, like they give you here, your first number is always going to be your x, and your second number is always going to be your y. So when you are given an ordered pair just like this, you look at your x value, and you're going to start at the origin, and you're going to move over to that corresponding number. So that means I need to move over to the number 5. Okay, so I stop there, but now I need to go up 4 because it's a positive 4. So 1, 2, 3, 4 straight up from 5, and my point would be right here. Okay, x is always to the left or right along your horizontal. Y is always up or down on your vertical. Okay? All right, then an ordered pair such as 5, 4 or 2, 3 is a pair of numbers used to locate a point on the coordinate plane. Okay, so we're going to put coordinate plane here. Now this page you have as a guide, so if you ever need to flip back or you don't know what any of these words mean, if they're talking about them in a problem, flip back to this page. Okay? All right, so let's go down to the bottom. The real world link. In 3 minutes, a North American wood turtle can travel about 17 yards. If the x-axis represents minutes and the y-axis represents yards, write an ordered pair to represent the situation. So that is saying that there's a rate going on, and that's usually why we have a coordinate plane happening, or why we are graphing something to show two things happening at once and how they are related to each other, where they connect. So we have minutes and a distance traveled. Okay, so just like our unit rates that we were finding. So in 3 minutes, if minutes represents our x and yards represents our y, 3 minutes they would travel 17 yards. Now what's cool about these is you're able to graph this eventually, and you're able to kind of graph points before it and points after it. So your unit rate, and you're able to see over time how long things may have changed, okay, or how long it took them to travel so many yards, whatever you're trying to find. All right, let's flip over to the next page. Now that we have kind of reviewed graphing in general, when you are given a ratio table just like in here, you can use the ordered pair or use the ratio table to create or graph your ordered pair. So they review x and y over here, which we kind of talked about. X again is horizontal, left and right. Y is vertical, up and down. Okay. So down below it says graph the ordered pairs. Well, luckily this is given to us. So this ratio table here, let's say this part of it wasn't here. You guys are used to filling out ratio tables just like this. If they give you a problem and they say, okay, the number of CDs, one CD costs $3, you would find if I want to buy 2, it would cost $6. If I want to buy 3, it would cost $9. 4 would cost $12, okay? So your ratio table is already filled out. Now what you're going to do is use each one of these points going across as part of your ordered pair. So now they said, okay, one CD costs $3. One CD costs $3. They graphed it down here. they made these two values, which are related, compared to each other, into an ordered pair. So 1, 3 goes here. 2 CDs equals $6, 2 equals 6. 3 CDs equals $9, 3, 9, 3, 9. You could even graph the next one. 4, we said 4 would be 12. So this is 9, 10, 11 would probably be about here. Okay, 4, 12. All right, now it says that all of them are graphed for you. You're going to describe the pattern. So you're looking at all of the ordered pairs that you have graphed. And what I would do when you're doing this is connect them. A lot of times you'll start at 0. You should always start at the origin and connect them and see what's going on. Put an arrow at the end of your line when you connect them, kind of like your connect the dot activities you did when you were little. Okay, so now it says describe this pattern. Well, could you, by looking at this, tell if something is increasing or something is decreasing just by the way that this arrow is pointing? It is pointing up, and you'll know that something that's going up like this is increasing. But if you know the coordinate or the coordinate plane very well, this section of it, sometimes you'll see that there's 4 sections or quadrants of it. This is just one tiny section of it. This is both positive and positive values. So that means it is increasing because both of my X and my Y are positive. And instead of them just saying, oh, it's increasing as their description, they used the two labels and the word increasing together. Okay, so they said the cost increases by $3 for every CD created. So when you're describing it, I would use your two labels, cost and number of CDs, and then the word increasing or decreasing to talk about what's going on. You could also say the more CDs you buy, the greater the cost. And that is what is being interpreted in this graph. So by looking at this graph, you know, all right, obviously the more CDs you buy, the more I'm going to pay. Okay, so that's what's going on in this graph. Let's look at this section down here. The table shows Gloria's earnings for 1, 2, and 3 hours. The table also lists this information as ordered pairs, which is nice for you. So if she works 1 hour, she gets paid, or 1 hour, she gets paid $5. If she works 2 hours, she gets paid $10. She works 3 hours, she gets $15. Okay? They have these ordered pairs set up for you. 1 is your X, 5 is your Y. 2 is your X, 10 is your Y. 3 is your X, and 15 is your Y. So they have 1, 5, 2, 10, 3, 15. So then it says, let's graph the ordered pairs. So if we go over, we have 1 to our right because it's positive. Right is positive, just like on your number line. Left would be negative, okay? Up would be positive, down would be negative. 1, 5. And now you notice that this graph here, zoom in a little, only has even numbers going up. It doesn't have a 5. So what do? You're going to put it halfway in between two numbers. So we have 1, 5. 5 would go right on this line here, halfway in between 4 and 6, because 5 is right in the middle. You'll see this a lot when they skip count like this, and that's just to save them room so that their graph isn't super big. Okay, so we got that one graphed. Now let's go to 2, 10. 2, and then we go up to 10. Okay, and then 3, 15. 3, 15 again is not on here, so I'll have to put it halfway in between 14 and 16. All right, so I have my 3 ordered pairs graphed. Now I'm going to connect them, and I'm actually going to start here just because it doesn't really go through the origin. And I'm going to put an arrow at the end because the more that she works, it's not necessarily saying that she stops at 3. She could continue on to 4, 5, 6, 10, 20, 30 hours, and her cost would still increase. So that's why we put an arrow at the end to show that it never stops. Okay? Now let's describe the pattern in the graph. It is increasing, okay, so we know that, and let's use our two labels here, hours and dollars earned. So we could say the more hours Gloria works, the more money she makes. You could also add in For every hour Gloria works, she makes $5, just like they did up here. And use your values, okay? All right, we're going to do one more, and then I'm going to give you your homework for today. So this one we're actually going to be creating or filling in the ratio table. So we're going to do on page 50, the guided practice, problem number 1, okay? And then you're going to graph it for me and describe it down below. But we're going to fill out the ratio table here, and then that way it's all set up ready to go when we do graph it. It says, 2 friends are each saving money in their bank accounts. Marcus saves $10 each week, while David saves $15 each week. Make a table for each friend that shows the total amount saved for 1, 2, 3, and 4 weeks. List the information as ordered pairs, weeks, and total dollars saved. So this is Marcus. He saves $10 a week. After week 1, how much money will he have saved? He will have $10. After 2 weeks, 20, 3 weeks, 30, 4 weeks, 40. Now let's make them into an ordered pair. So we have 1, 10, our x and our y, and look at, they tell us right here, x and y, 2, 20, 3, 30, and 4, 40. Okay, now let's fill out David's. David's is 15 every week. So after week 1, he will have $15 saved. After week 2, 30, week 3, 45, and week 4, 60. All right, now let's do 1, 15, 2, 30, 3, 45, and 4, 60. All right, we have this set up. Let's go ahead and graph it. Why not? Let's just graph the ordered pairs down here. Okay, so now it says graph the ordered pairs for each friend on the same coordinate plane. So we're going to have 2 lines going on this one, not just one. So it might get a little tricky. What you might want to do is use 2 different colors. I'm going to use red for Marcus, and I'll use black for David, just to kind of see the difference between the 2. Okay? All right, now let's see. Marcus, week 1, 1, 10, 1, 10. Week 2, 2, 20, 3, 30, and 4, 40. Okay, so I'm going to connect his points. I'm going to go past the graph and put an arrow at the end to show that the more weeks he goes, he will continue. He doesn't just stop at week 4. All right, now let's go to David. David has 1, 15, 2, 30, 3, 45, and 4, 60. I'm going to connect those going this way, put my arrow here. What do you notice about this graph? What's going on between the 2? What do you notice about Marcus's line, the red line, and David's line, the black line? So now question 3 says, how do the ratios of Marcus's savings and David's savings compare? How is this shown on the graph? Well, what do we notice about the lines? They're both increasing. So we know that the more weeks that they save, the more money they will have saved. Okay, but how are they different? What can we see about the slope, or how is this red line increasing versus this? And you'll notice that the black line is increasing steeper. It's a steeper hill. Think about these as hills. This would not be as fun to climb. Okay, this would be a lot of work. This one would be a little easier, still steep, still positive and increasing, but it's got a little bit lower and slower of a slope. So David is actually saving more money per week, and he's going to have a greater savings because he's saving at a greater rate. Okay, so this is a little bit steeper of a slope. So what we can do is say, how do the ratios of Marcus's savings and David's savings compare? How is this shown in the graph? David is saving more money each week, and I'll move my hand in a second, compared to Marcus, which is shown in the graph with a steeper line. Okay, David is saving more money each week compared to Marcus, which is shown in the graph with a steeper line. So by the end of 4 weeks, David's going to have more money saved up than Marcus because he's adding more to his account each week. Okay, your homework today is going to be page 51. You are going to do problems 1 and 2 and 3 and 4. Okay, so you're going to do the whole page today, page 51, the whole page. All right, let me know if you have any questions, and good luck.